In this session, we're going to focus on resilient distributed datasets, or RDDs for short. RDDs are Spark's distributed collections abstraction, and they're really at the core of Spark. In this session, we're going to learn the basics of RDDs, and we're going to learn a little bit about the APIs that are available, and we're going to consider some of the basic differences between the RDD API and APIs that you may be more familiar with in collections. So off the bat, RDDs seem a lot like immutable sequential or parallel collections. So think about, for example, a list. Lists in Scala are immutable collections, and we often use them with higher-order functions like map, flat map, or filter. Just like lists, RDDs have a similar API full of lots of higher-order functions like map, flat map, filter, reduce. This is a simplified definition of the RDD class. Of course, there are many more methods, and it's much more complex than this, but this is a simplification of the RDD class as defined in the Spark codebase. And as you can see, these signatures all look very familiar. They look just like the signatures that we've seen on lists for things like filter, flat map, and map. And it's important to note that RDDs really make heavy use of higher-order functions. So just as a reminder, higher-order functions are operations like map, flat map, filter. They're methods or functions that take as an argument another function. So just to look at some more methods on both RDDs and lists, also other parallel and sequential collections, map, flat map, filter, reduce, fold, aggregate, all of these things exist as well on RDDs. So we have really some of the core APIs still available to us that we're already used to in sequential collections on RDDs. They even have mostly the same signatures, macroscopically, of course. So in the case of RDDs, of course, the return type is going to be an RDD rather than a list if we compare the signatures of map, flat map, and filter. Otherwise, everything is basically the same. In the case of map, both RDDs and lists take a function from A to B and apply this to all of the elements in the collection. The same is true for flat map and filter. When we look at these reduction operations, same thing. We have effectively the same signatures. The only difference is aggregate. As you can see here, in the case of Scala's sequential and parallel collection, aggregate has its 0 as a by name parameter, whereas in Spark it's not. Do you have any idea why this might be? I'll give you a hint, but I'd like you to think about it on your own and perhaps discuss it in the forums. Remember distribution. Remember that we're going to send things to another computer. So think a little bit about whether or not a by name parameter is the best idea versus something that is not by name when it comes to having to distribute code. So I hope by just looking at some of these basic APIs, you'll agree that using RDDs in Spark, it looks a lot like, a normal Scala sequential or parallel collection. The only difference is that you know that your data is distributed amongst several machines. So assuming we don't know anything else about RDDs, and we only know Scala's Collections API, let's try to solve a simple problem with Scala's Collections API and see if it works for RDDs. So let's assume we have an RDD full of encyclopedia articles. Each encyclopedia article, each string represents the text of one article, for example. And let's just say we want to search this RDD full of these articles or these article pages, and we'd like to count the number of times that EPFL, the university that the Scala programming language is developed at, let's say we want to count the number of times that the pages mention EPFL. What would we do? How would one write this code knowing that we have something called encyclopedia, and we want to search for mentions of EPFL and then sum up the mentions of EPFL? Well, it looks very much like regular Scala collections. This is all you need to do. So assuming that each page is a string, and all I got to do is do page.contains my substring, so in this case EPFL, all I got to do is do encyclopedia.filter, and I have this very simple predicate, and then I can just count the number of pages that have EPFL in the text. That's it. It looks exactly the same as how you would do it on a list. Let's look at another example. So word count is the hello world of programming with large-scale data. How would we do word count in Spark? Hint, looks a lot like Scala collections. So let's assume we have an RDD. This is an example of one way you can create an RDD. We'll talk more about how to create RDDs later. But let's say I've created an RDD called RDD, and now I want to count all of the words in this RDD. The signature isn't written here, but let's assume that this RDD has type RDD string. And let's assume that each string represents a line of text in a text file. So what do? If we had a regular Scala list, we could use flatmap to take each individual line and then split each individual line into individual words. Now you have a collection of individual words, and then we flatten that back down all to one collection. So the result of this here is, again, an RDD of string. But this one represents now words. So it represents an RDD of all of the words in this base RDD that contains lines of a text file. Next, what we can do is we can map every single word in the RDD to a pair of word and the number 1. So we have something that we can now sum up and count. So then, next step would be to use a reduce operation. So reduce by key is a little bit special for Spark. We'll look a little bit more into depth about exactly the differences later. However, what we're doing here now is we're just summing up the ones in the pairs. That's it. Now we have a count of all of the words in this text file. What's important to note is that we've done word count in only 3 lines of code. Another reason why people tend to favor Spark over Hadoop is that this program can be done in so few lines of code so clearly, whereas if one had to write this program in Hadoop, it would take many more lines of code of lots of boilerplate. So people find Spark also much more concise than Hadoop. So the last thing we're going to discuss in this lecture is the different ways that one can create an RDD. So how might you create an RDD? There are 2 main ways that we can create RDDs, either by transforming an existing RDD or from something called the Spark context, or in later versions of Spark, it's being renamed to Spark session. But we have this thing called a Spark context or a Spark session. It's an object, and you can populate a brand new RDD with it. Either you populate a brand new RDD with this Spark context or Spark session, or you can get an RDD from an existing RDD. So in the case of transforming an existing RDD, it's just like when you call a high-order function like map on a list. You get a new list back. In the same exact way, when you call a map, for example, on an RDD, you get back a new RDD. So you can get an RDD as a result of doing a transformation on another RDD, just like you can with lists. Now, the other way is to use this Spark context or Spark session object, as I mentioned earlier. This is important to remember, because you're going to see this in your assignments later. Remember what this Spark context or the Spark session object is, because this thing might have a weird name, but this is the handle to the Spark cluster. This is how you talk to Spark. You talk to Spark always through this thing called the Spark context. So whenever you want to start a new Spark job, you got to create a Spark context first. You got to pass some parameters to it to configure your Spark job. And then you got to start creating RDDs using this Spark context. Now, this Spark context does a lot of the smart work surrounding distribution. It figures out lots of things that you don't want to ever have to worry about. Most important to remember that this is your handle to your Spark cluster. And the 2 methods that are the most important to remember that we're going to see in all of the subsequent slides and in the assignments are parallelize and text file. Parallelize creates an RDD out of a regular Scala collection. You're not really going to come across this in real code bases where you're doing really big jobs, because the assumption is that you've already got the collection in memory in a Scala collection, like in a list or something else, and now you just want to create an RDD. Most of the time, when you're using large data sets, you're going to be using this text file method, which basically can read a text file, usually from HDFS, Hadoop's file system, or a local file system like a regular text file, and then return an RDD of strings. So after you get this RDD of strings back, then you need to figure out how to transform it into something else. If you don't want it to be strings, maybe you want it to be integers or something like this. But the text file will return an RDD that you can then do all kinds of subsequent transformations and analyses with. In the next session, we're going to delve a little bit deeper into RDDs and some of the most important operations that exist on RDDs, transformations and actions.